Hey everyone, welcome to The Explainer. Today, we're diving into the pretty fascinating world of acids and bases. Chemistry can sometimes feel a bit intimidating, right? All those complex equations and dangerous chemicals. But honestly, at its core, it's really just the study of the stuff all around us. Today, we're looking at some source material that shows how you can unlock the hidden identities of everyday items, stuff literally sitting in your kitchen cabinets right now, using nothing but a tiny strip of paper. It's colorful, it's instant, and yeah, it's incredibly fun. So here's the core question we're tackling today. How do we actually know if a liquid is acidic or basic? Imagine you've got two identical glasses of clear liquid right in front of you. One is pure water and the other is white vinegar. They look exactly the same. They might even flow exactly the same. But chemically, they're worlds apart. Now, obviously, we can't just go around tasting unknown liquids. That's like rule number one of what not to do in science. And we definitely shouldn't be touching them to find out either. So how do we decode the unseen chemical nature of these everyday liquids safely and accurately? Well, we need a tool, basically a decoder ring for the chemical world. All right, here is our roadmap for today. First up, the magic of chemical color change. Second, what we need to start. Third, the golden rule of colors. Fourth, practical experiment steps. Fifth, the scientific secret behind it. And finally, trying it yourself at home. Section 1. The magic of chemical color change. So, litmus paper is essentially a magical detector. It really is one of the absolute easiest, safest, and frankly most fun ways to detect if a substance is acidic or alkaline, which, by the way, is just another word for basic. What makes it so brilliant is just how simple it is. There are no digital screens to calibrate and no complicated readouts to try and interpret. It just gives you a straight-up, binary visual answer. It literally takes the invisible chemical world and translates it into a language our eyes instantly understand, the language of color. Moving on to Section 2. What do we need to start? The best part about this experiment is incredibly accessible. You really don't need a high-tech lab to do real science. First and foremost, you just need the star of the show, blue and red litmus paper. Super easy to find online or at educational supply stores. Next up, our test subjects. For your acidic materials, grab some fresh lemon juice or standard white vinegar. For the basic materials, everyday liquid hand soap works perfectly, or you could just mix up a solution of baking soda and water. And finally, to handle the liquids with a bit of precision, grab a dropper, though hey, cotton swabs work just as well, and a few small cups to hold your samples. That is it. With these simple, everyday items, you are completely ready to go. Section 3. The golden rule of colors. Okay, so here's a really fun fact from our source material. In Arabic, the word for acid actually shares a common letter with their word for red, and their word for base shares a letter with blue. Pretty cool, right? But for English speakers, we have our own brilliantly simple, foolproof trick. Basic equals blue. Both start with the letter B. If the paper turns blue, it's a base. And by process of elimination, acidic equals red. Just memorize that simple B to B connection, and I promise you will never get your test results mixed up. Let's look at how these substances actually behave in action, because this is where the mechanics of the test really click. If you take an acidic substance, like our lemon juice, and drop it on blue paper, it turns red. But drop it on red paper, absolutely nothing happens. It just stays red. On the flip side, take a basic substance like our soap. It does absolutely nothing to blue paper, but drop it on the red paper and boom, it turns blue. And what about something perfectly neutral, like pure water? It causes zero color change. Blue stays blue and red stays red. It's a perfectly elegant, naturally occurring diagnostic system. Section 4. Practical experiment steps. All right, here is exactly how you run the test. Step 1. Let's get organized. Prepare your samples by putting a little bit of lemon juice in one cup and a little soapy water in another. Keep them separate. Step 2. We test the acid. Take a strip of your blue litmus paper, lay it flat, use your dropper to pull up a tiny bit of lemon juice, and let a single drop fall right onto the blue paper. Instantly, right before your eyes, that blue paper is going to shift to a bright, vibrant red exactly where the drop hit. It is seriously so satisfying to watch. Step 3, we test the base. Take a fresh strip of red litmus paper, drop some soapy water onto it, and just like magic, the red paper instantly turns a deep, cool blue. You've just successfully tested both ends of the pH spectrum right there on your kitchen counter. Section 5, the scientific secret behind it. Okay, now this is the part that absolutely blows my mind. We buy this paper in a store, right? But it's actually not some synthetic, lab-created anomaly. Litmus paper contains natural pigments extracted from the lichen plant. You know, lichens? Those fascinating, crusty, moss-like organisms you often see growing on rocks and tree trunks out in the forest? Well, nature actually provided us with these specific pigments that are highly sensitive to their chemical environment. When they come into contact with acids and bases, they undergo this rapid, reversible chemical reaction that fundamentally changes how they absorb and reflect light. It all comes down to what exactly those lichen pigments are reacting to. Hydrogen ions are basically the hallmark of acidic solutions. When the pigments in the paper detect these hydrogen ions, their molecular structure actually shifts slightly, and that makes them reflect red light. Conversely, hydroxide ions are the signature of basic or alkaline solutions. When the paper detects those hydroxide ions, it triggers a totally different structural shift, causing the pigment to reflect blue light. So the paper isn't just randomly changing color, it is literally counting the invisible ions in the liquid and giving you a visual report. And finally, Section 6, try it yourself at home. To wrap things up, I want to leave you with a bit of a challenge. Think about everyday items like milk, soda, or toothpaste. You interact with them all the time. But do you actually know their true chemical nature? Are they hiding hydrogen ions, or are they packed with hydroxide ions? I challenge you to take your newly learned golden rule, remember, base equals blue, get yourself some litmus paper and start testing. Mix a little toothpaste with water, drop it on the paper, see what happens to your favorite soda. The world around you is literally full of these invisible chemical secrets just waiting to be decoded. So what are you waiting for? Get testing and see what you discover.